Okay, so at this stage my recommendation is that you, when you finish with all changes, just make sure that your AST node evaluate method is complete and it handles all of the operators, plus, minus, divide, multiply, that everything works correctly. And the next and final stage of this assignment is to implement the assignment operator. And basically this is, of course, assignment has to work for variables. So before we can add assignment, we of course need to add support for variables, which is the biggest part of this final stage. So of course variables have to persist in calculator's memory. So for instance, we can say x equals 1, y equals 2, and then we can say z equals x plus y. So x plus y remain in memory, and so the variables persist between individual expressions, so we can continue using them. So of course, if x and y are 1 and 2, then the last expression yields 3 in the variable z. So the user can continue using and updating these variables, and of course they can now be used in place of numbers in our expressions. So that's the idea of implementing the assignment operator. Optionally, I would also think about, this is optional, and I just want you to think about how would you get rid of an existing variable. So the main method does have a special command handling such as quit, right? So it's very simple. So I'm still running my program, so now I can say quit, and the quit will take me out. So we, in addition to what the expressions do, we can also add other commands, and we could consider using a separate command that would remove the variable in memory. So we could say delete x or delete y and so forth. But of course this is the stage, I mean this is something extra you can think about, and you're not required to do this. So let's talk about variables. And here I'll just go back to our source code, and we'll try to map what's outlined in this handout to the source code that we have already in place in this prototype. So I'll just guide you through this step by step indeed. So let's see. So the first step is that if you look at the AST node, inside the AST node, which is from what the entire syntax tree is constructed, we have this type. And so the type can be a number, it can be a marker of an AND, it can be an error, and of course it can be plus, minus, multiply, and divide. So what we need to do is that we need to add another type of node that would represent the variable. So this statement, public static final int identifier, goes right here. Okay, so we add another constant that represents brand new node, and we call this identifier, and this is the type of the node that we'll be using for nodes that encapsulate variables. Next, we need to store variables in memory. So compiler typically refer to this type of data structure as a symbol table. So variables become symbols in this table, and there we store the values. So we actually use hash map to store symbol table. So we can take the static public and add this to AST node. It's static, so we can insert it right at the top, right? So we could have done this, and again we can just press Alt Enter and say import hash map. And so here the AST node will contain the actual instance, only one instance. This is static, hash map, and it maps string, which will be the name of the variable, to the double, which of course is the value of the variable, and we call it symbol table, and we are going to construct this. This is of course static data member inside the AST node, so you can see that this line right here goes right here or anywhere else, but let's keep it right at the top. So pretty much done with this. So now we have the placeholder, the symbol table, to store our variables. Okay, so of course it's static so that it can persist between subsequent expressions. Now this persistence issue is important, because if we take another look at the main, we create input, which is string builder. We create the lexer that takes the input. We call lexer start rule. Then we do our evaluation. We have the result. And then what happens? We just loop forever. So basically we go from here back to the top of our endless loop, and everything is gone except this hash map that we call symbol table, because we make it static. So it will continue to exist between execution of multiple expressions, and that's what we need to do so that the user can run multiple expressions right here, but the new variables can accumulate and can be retained. Alright, so this is just a note about persistence, and we can move on. So since the lexer now has to use the symbol table, we can add an attribute to the lexer class. So basically the idea is that because the lexer has to be able to access the symbol table, we need to basically go to the lexer, right, and go to its constructor, which I normally keep somewhere at the top. So the current version of the constructor is this, and we just need to replace this version with the modified version. So we need to take all of this, okay, and replace all of this with this. Okay, so this is just we replace it like that. So this will be the new constructor. So this new constructor right here is taking a symbol table, but this is only a reference. It's not going to duplicate the symbol table. It's only going to take a reference to symbol table. And of course, we also need to remember this reference somewhere in the lexer. So in the lexer, we just store a reference like this. And of course, also we need to Alt-Enter and say import, so that we need the proper import for the symbol table. But this is not creation of the new table. It's only the reference so that the lexer object can have access to our symbol table. So we just replace this here, as we mentioned, with this. And in the main method, so right here in the main method, we need to switch over here, and what we need to do is that we need to replace this call to the constructor with the new version of the call that looks like this. Okay, so I'll just increase this a little bit. So we just need to replace this part with this part, just like this, right? So this here an extra parameter that we pass the reference to symbol table to the lexer, so that the lexer now has access to the symbol table, which is retained by AST node, a static data member that we added. So the next stage is that we need in the token stream, we need to deal with identifiers, and we would like to have this check for an identifier which checks for an alphabetical name like XYZ or ABC or whatever is the name of the variable. So we go to the token stream, and we can just go anywhere here. We can go to the very bottom, There are checks for is string, is number, and now this would be the right place right here to insert this new method into our token stream and basically copy and paste and insert it right here in the token stream class. So we have brand new method that's named identifier, is identifier. So this method should take it easy to detect variables in a stream of tokens. And of course, the calls to this method will be coming from our lexer as it goes and tries to understand the tokens in the input. Okay, so what we're going to do next. So now this is the largest portion, the biggest change that we need to take. So we need to go to the primary rule. Now remember, if we switch again to the lexer, and if we scroll down here, the proposition is that we handle assignment of variables at the primary level. So we're going to go to the primary rule, which implements all of this, and we're going to handle this. Okay, so what we're going to do is that we're going to add this new code to handle variables and variable assignment. So now what I should say here is that we will also recognize individual variables as primaries, right? So name is a primary, and name equals expression is also a primary. So these two things we're going to handle by this new addition. So let's go and find the primary rule inside our lexer class. So we're going to scroll up, and this is our primary rule right here, right? So it's the implementation of it. After checking for the end, really we can insert it at the top, at the bottom, it doesn't matter. Basically, we take this if statement, right? We take this new code, this if statement, and we can place it inside the primary rule. How about we do it right here, right? So we can just sort of like show where we want to insert this. I'll just create these separation lines to make everything safe, copy, right, and paste right here. Okay, so this would be okay because we already have a token stream identifier added to token stream AST node and identifier and all of this. So this code will handle the assignment. Of course, assignment is a binary operator. So here we check whether we have in the token stream where so we're already detecting that we have an identifier, so we instantly construct new node, which is the identifier, and store the value of the token is the name of the variable. And then we check whether, so if nothing else is present in the token stream, we just return the primary. So we just return the node which represents the identifier, the name of the variable. However, if equal sign is present, so we have an actual assignment going on, we create the fork, we store the primary, this identifier type of node. Basically, we store it as a left-hand side and then the right-hand side. So what is going to be happening here is that we're going to construct this right here, this fork node, okay, which will be storing the type of the node will be a character at 0, which is the identifier, right, which is this equal sign. So this will be a node like this, and it will store the primary, which is the name of the variable, as its left hand side right here, right? And then it will implement the idea of the expression rule, and this will become whatever is returned by this expression on the right hand side of the assignment will be the right node. Okay, so for instance, if we have an expression x equals 5, right? If we have this assignment expression, then the outcome of this addition here will be a plus. The node that represents, oh, I'm sorry, no, I have to redo this one more time, right? So x equals 5, okay, and so there will be this made up, and then there will be an x, and this will be the identifier type node over here, and over here we'll have something that stores literal 5. So this will be the numeric node that stores this. If there was an expression 5 plus another variable y, right? 5 plus y, then of course here will be a plus, right? And here will be 5, and here we'll end up having y. And all of this will be handled by this expression, because expression can do everything inside the parentheses, and we can attach pretty complex expression to, on the right hand side of our assignment. So this is this step. Okay, so this is handled by our primary rule, and you can see that I just showed you how you can insert this portion directly here at the top, and it should work pretty well if you work in sequence, just doing everything step by step accurately. And at this point it should be possible to build a project and do a little bit of testing. So this would show you if you bring back the printing of the nodes. We just comment this out because we were so anxious to test evaluation as soon as possible. But if you bring back printing the structure of the tree, you should be able to successfully check this and see that you indeed construct the assignment right here. And this is the rest. So we have the x, which is the name of the variable, and we have this right here on the right hand side. And so finally, in the evaluate, right, so now we already have our AST node evaluate, which we already started earlier. So we have our evaluate method already started here. So we're just gonna basically we can here the thinking was that maybe we can use the switch, but similarly we can just do what we did with else if structure. So we can paste it right here and say if the type is the assignment, right? So actually first, if this is the identifier, okay, if this is an identifier, then we go to the symbol table and we say if it contains specific value, return, and all of this. So we can do this over here, okay, or just basically just copy and paste this portion right here, because if we're using this if else, then we can do it like this. Okay, otherwise we print undefined variable and just complain that the variable is undefined. And we can also add another else if right here, because I started using else if earlier. I'm not going to change everything to a switch this late, so I'm just going to say, okay, if it's an assignment, then this is what's going to happen, right? So if this is an assignment, so right here we'll just change it to the assignment. So if the type truly is an assignment, then what we're about to do is just going to say, okay, the right value will be the double value. Of course, it's the right hand side of the assignment, and then a symbol table store, which is put, basically left node value. Here is the name of the variable, and this is the value of the variable, and then return the same value from evaluate. So this is this portion basically slightly modified. So I'll just highlight this right here. Right, so this portion right here in my evaluate sequence of else if corresponds directly to this entire entire portion of the evaluate if evaluate was implemented as a switch on the type, right? So basically, I kind of transformed this logic over here to use else if version of this logic. I'm not using switch. I'm using if, else if, else if. Okay, so this is the demonstration. So this is the final part. And once you have it in place, then all you need to do is just verify that everything works, and everything should be just fine. And of course, as always, I want you to zip your source code and submit the results so I can check your work. And I hope you can have fun with this desktop calculator and try to tweak it and make sure that it works. All right, so we're done with this description of desktop calculator. I also would like to recommend that if you have any questions or concerns or some kind of difficulty working on this, I know it's a long presentation about this desktop calculator. There really isn't that much writing of the code, but it's mostly the understanding of how everything is connected together. So be sure to post your questions on the discussion forum, subscribe to the discussion forum, and of course, if you know the answer, you can just help out other students and you can interact nicely on the discussion forum. And of course, I will be monitoring the discussion forum myself, so I'll give it some time so that maybe you can communicate with each other. But if I realize that you need help, then I'll post my answer to the discussion forum. So good luck with this assignment.